All right, now we're to the point where we know what reaction symbols mean. We know about the state symbols, solid, liquid, gas, aqueous. We know that if we ever create a compound, we need to check charges. And if we ever see an element by itself, then it's an element and we need to see if it's a diatomic element. Now, there may be something that's bugging you up to this point, and so we're going to pause here. And when I say pause, it's going to be a couple of days because this is a skill we've got to work on. And we're going to learn to balance equations, because there might be something bugging you. I want to kind of bring that up here on this next slide. I do also want to point out that today's balancing of chemical equations is what I would call the introductory level. There are more challenging equations to balance, but if you get the basic idea today, you're going to find the rest of it to be just fine. It's just really showing you other kinds of examples. Okay, so let's look and figure out how to do this. By the way, I'm going to change my marker color really quickly to something visible. And let's look at this equation. So this equation, I think, is something that might cause you to hesitate and say, did we do something wrong here? I mean, if you think about it, step one is to make sure that you have the formulas written correctly. And do we have the formula written correctly over here? Yeah, we check charges. Na is +1, chloride's -1. It really is just one Na and one Cl. And over here, these are elements by themselves. And we were right that chlorine is a Brinkelhoff element. It's a diatomic element, so it needs that little 2 there. Now, what I'm talking about that there may be a problem is if you think about this, if these are the reactants, right? These are the things that we brought into lab. They're like the ingredients, right? If you brought in 1 sodium atom and 2 chlorine atoms, I understand that they're going to rearrange, they're going to make and break bonds, but how is it possible that at the end you only have 1 chlorine atom? Doesn't it seem like a chlorine atom just kind of disappeared out of thin air there? That's a problem. And it's not that we didn't write the formulas correctly. That really is the formula of chlorine. In other words, we could not come in here and just throw a 2 on here. We can't do that. And the reason we can't do that is because that's not the formula of sodium chloride when we check charges. It's not a proper formula. So how do we deal with this problem? And the answer is equations must be balanced. This is what happens after you write formulas. So the way you balance equations is you can't mess with the formulas because we already did a good job, right, writing the formulas. But we can add something called coefficients. Coefficients are large numbers that go in front of the chemicals that tell you how many of each one you're including. In other words, we don't have to have just 1 sodium and 1 chlorine to do this reaction. That's not a requirement. We could, say, use a couple of chlorines and maybe 3 sodiums, and that's what balancing equations will help us figure out. So how do we do this? Well, I am going to have some tips for you, and I will tell you there are some shorter ways and faster ways to do it, but it all comes down to this idea that you need to divide things in sort of a before area and an after area. In other words, the reactants beforehand, we need to have the same number of sodium atoms before we do the reaction as we have after. Now you can see that we do. We have 1 sodium ion beforehand and we have 1 sodium ion afterwards. We're good to go, right? But the problem is beforehand, we actually have 2 chlorine atoms. See, we got 2 chlorine atoms. That's a problem. And over here, we've already said I can't put a 2 on there. I can only change the coefficients. Because if I do anything by changing subscripts, I'm messing with formulas that are already okay. So these lines in front are the only places that you can change values. And if you put a number there, it's got to be a large number. And what you're saying is you have more than one of those type of compounds. So if I want 2 chlorines on the right to match the 2 chlorines on the left, I'm going to put a big 2 there like that. So that means now effectively what I'm saying, and let me do a kind of a cutoff line here, is what I'm saying is afterwards I'm going to make 2 sodium chlorides, right? That's what that little 2 means, is I'm going to make 2 sodium chlorides, and therefore I get to have 2 chlorine atoms. But you can see the problem is if I make 2 sodium chlorides, I don't just get 2 chlorine atoms, I also have made 2 sodium atoms. So this number in front means I have 2 of everything in that formula, and so I need to write it down twice so I understand it's not just 2 chlorines, it's also 2 sodiums. Well, right now, if I don't put any numbers over here, I've got 1 sodium and I've got 1 Cl2. You can see that I have 2 chlorines, it looks pretty good, but I only have 2 sodiums over here, and I only have 1 sodium over there. So clearly this side is going to need more. So I'm going to notch this up from a 1, because if I don't have anything there, it means 1, to a 2. And now I have 2 sodiums, so I can add my list. I've got 2 sodiums. I've still only got 2 chlorines, but now that matches on my after side. I have 2 sodiums. Yeah, there you go. It's balanced. And 2 chlorines, that's balanced as well. So now I have the same number of sodiums in the before area as I do the after area. And if you get done, you don't have to put anything in the slot. But if you want to, you know what number it represents? It's a 1. And a lot of times we like to put a 1 there, but you don't have to, right? I will tell you, chemists don't draw the lines where the coefficients do. I'm just putting them there so that you know that that's the only place that you can balance the equation. So there you go. This is the balanced equation. So we write formulas first, right? We check charges and make sure the formulas are correct. We look for diatomic elements, but when we're done, we need to balance the equation. Now there's a reason for this, and the reason is the law of conservation of mass. What the law of conservation of mass says, and you may have heard it before, is mass cannot be created and it cannot be destroyed. If we had had 2 chlorines in the beginning and had none afterwards, it would appear like we had destroyed some mass. A chlorine disappeared. That's getting rid of some mass. I mean, after all, where's the periodic table? Chlorine weighs 35.45. That would be some mass that would disappear if we magically made a chlorine go away. So the law of conservation of mass means we have to have the same number of atoms in the beginning as we have in the end so that we don't lose any mass. So you must have the same number and type of each atom after the reaction finishes as you've had at the beginning. So really this just takes a little bit of practice. Now we're going to look at some simple examples today, and in the next lesson we're going to look at some slightly more complicated ones. So let's look at this one. We know that we have an imbalance of atoms here. If you look at it, you probably see. Actually, let's start right here. If I divide things up in the before and after, this is the before area, and this is the after area. Do you guys see that the hydrogens are balanced? I have the same number as before as after. But is it the before area or the after area where I need more oxygens? Definitely the after area. Do you see those oxygens? I only have 1 here, right? There's no numbers, so there's only 1. But I have 2 oxygens here. All right, this is an equation that needs to be balanced. So how am I going to do it? I'm not going to change the subscripts. I'm only going to add coefficients on those lines. Okay, now you can start, here's a general rule of thumb. You can start with any atom you want to. Now, in the next lesson, I'm going to suggest that we start with a particular atom, but in this one, we're going to start with any one we want to. We've already decided that beforehand, we have 2 hydrogens. And you remember, I'm going to kind of keep track of my before and after down here. If I don't have any numbers on these lines, it means I have 1 of each one. So I have an H2, I have an O2, and I have an H2O. And if I notch that up to 3, I'll write 3 waters, right? Okay, so let's see. The hydrogens are balanced. I have 2 on the left side and 2 on the right side. But let's do the oxygen. You just said that we need more oxygens on the right. So I'm going to notch this up from 1 to 2. Now I have 2 waters. Now looking down here at my 2 waters, would you agree I have 2 O's? Fantastic. I have 2 O's there. But we're not done. On the after side, how many hydrogens do I have now? 4. I have 4 hydrogens, but if I go over here, I only have 2. So I'm going to notch this up to a 2, and that gives me another hydrogen, because that's what that 2 means in front. It means I have 2 hydrogens, right? So I have another one, and you got to write it down exactly. You see how this green H2 looks like H2? You got to write it down exactly the same way. So now I have 2 of them. That's 4 hydrogens, 4 hydrogens. The hydrogens are balanced. I have 1 O2, because I didn't do anything with that. There it goes. That's 2 oxygens. And over here I have 2 oxygens. We're good to go. So the reason why we draw down the green chemical exactly the same as we add another one is because that's what the coefficient means. Is it means we have a whole nother compound or element, right? That number in front affects everything. So there we go. I think we're balanced on this one. Okay? Now, if you're feeling uncertain about this, and generally speaking at this point, people either feel like, yeah, I got this, just cut me loose and let me do it. Or they're feeling like, If that's you, if you're feeling uncertain about it, just be patient. It gets way easier the more of these you try. Let's try this one. Now, this one I'm going to divide into the before and after area. Now, before I bring up my coefficient lines, I want you to look at this. You can pick any element you want to. I want you to pick one element. Let's do calcium. Honestly, if we were in class, I'd just let you choose. It doesn't matter, just pick one. I'm going to pick calcium. Are the calciums balanced on the before and after side? No, they aren't. Do we need more calciums on the left or the right side? Now, I do agree with you, we need more calciums on the right side. But the thing you should know is we may have to erase and fix the work that we do as we go through this. A lot of times if you pick one element and you kind of balance things, you have to go back and fix things later. So we're always going to check and see at the end if we're done. All right, so I'm going to divide this up. Let's see, right now you guys know before I put my coefficient lines on there, it means I have one of each one of these. Agreed? That's what it means. If I don't put, it doesn't mean 0. It means I have one of each one of these. So I'm going to put 1 down for each one of them. All right, now according to you guys, I need more calciums on the right. I only have 1 calcium over here, but I have 3 over there. So I'm going to put a 3 here so that I have 3 of these calcium oxides, right? That's what that means, is I have 3 of those compounds. Now I have 1, 2, 3 oxygens. Oh, sorry, 1, 2, 3 calciums. I lost track of what I was doing. And 3 calciums. Looks good. What element should we do next? Now, if we were in class, I just let you choose. We'd either go on to nitrogen or we'd go on to oxygen. It's up to you. But I'm going to pick randomly. I'm going to say, let's do it alphabetically. Let's do N next, okay? All right, how many N's do you see on the left side? I see 2. How many N's do you see on the right side? 2, right? It's good to go. It's already balanced. Looks great. Let's go on to O. I see 2 O's on this side. How many O's do you see on the right? Now remember, there's not just 1, this 3 affected it. Remember that 3 meant there were 3 of those calcium oxide compounds. So there's actually 1, 2, 3 O's there, but there's only 2 over here. Wouldn't you agree we need more over here? Well, if I put a 2 here, how many oxygens do I now have on the left side? 4. But over here, I only have 1, 2, 3. Okay, I told you we might have to erase. Let's go do some erasing. I'm going to erase this. And if I need 4 over there, let me get my pen back. Let me try 4. 4 calcium oxide molecules. Maybe I'll add it at the top here. 1, 2, 3, 4 oxygens. 1, 2, 3, 4 oxygens. Looks fantastic. The oxygens are balanced. Are the nitrogens still balanced? Yep, I've got 2 and I've got 2. Looks fantastic. Are the calciums still balanced? No, I have 1, 2, 3, 4 calciums, and over here I only have 3. Oof. Clearly we need more over here. Would you agree? All right, so I'm going to put a 2 here now because it was 1. I'm going to draw down another one. 3 and 2. Now I have 3 plus 3. I have 6 calciums, but over here I only have 1, 2, 3, 4. We're going to need more over here. So do you see how I'm just going back and forth and fixing things as they become a problem? Let me come back over here. Let's go like this. So we needed 3 plus 3, we needed 6. So I'm going to go 6. Let's see, 1, 2, 3, 4 of these molecules, 5. I'm going to have to add another one right here. So now I have 6 calciums and I have 1, 2, 3, 4, 5, 6 calciums. Looks pretty good. Now, before we're done, we fixed our calciums. It's always good at the end. You need to check and make sure everything else is still okay. Are the nitrogens still okay? No. How many nitrogens do I have on this side? 4. And over there I only have 2. I got to fix that. So what number do I put here? I'm going to put a 2. That's going to give me another one of those. Now I have 4. Okay, thank goodness we checked that. Are we done? No. Let's check this out. Oxygens, I have 4 over here. How many do I have over here? 1, 2, 3, 4, 5, 6. I have 6 over there. Clearly, I need more on this side over here. So let me, what number do you think I should put here? I need 6 oxygens. What number do you think I should put here to get 6? A 3. Because that would give me 3 O2s. There's 1, there's 2, there's another one. That's 6 O2s. Now, if you're sitting here looking at this going, oh, I get it. If I just multiply 3 times 2, that gives me 6. You're right. That's another way to do it. I kind of like these lists at the bottom because it reminds us that each time we change this number, we're saying we have 3 of these O2s. So draw it out. 2, 4, 6. I can clearly see there's 6 oxygens. 1, 2, 3, 4, 5, 6. Looks fantastic, right? Over here I have 2 of these guys. So let's see. That gives me 6 calciums. 1, 2, 3, 4, 5, 6 calciums. Looks great. I have 4 nitrogens. 2, 4 nitrogens. And there we go. We're balanced. So how do you decide which element to start with? Just choose one and balance it and then go on to the next one. But before you're done, you always got to double check that all of the atoms are balanced. Let's keep going. All right, let's try this one out. So in this one, I want you to work ahead. I want you to draw this thing on paper. I want you to add those coefficient lines because that's the only thing that you can change. And I want you to balance it. And then I want you to type in the coefficients that you get. Okay, let me show you how I would do it. I divide my paper in half. This is the before area. This is the after, right? Our reactants and products have to have the same number of atoms. Okay, we can choose any element we want to. I'm going to choose aluminum because it comes first alphabetically. That's not actually a rule. I will have a rule later, but let's try it out. I have, let's see. Remember, if I don't have any numbers in here, that means I just have one of each one of them. So let me divide up my area. I got one of these compounds, one of these compounds, and one of those compounds. All right. Now, I have 2 aluminums over here and 1 over there. Clearly, we're going to need more on which side? Yep. So what number goes here? A 2. So that means I have 2 aluminums. I'm going to add another one. There we go. 2 aluminums, 2 aluminums. Now let's do our oxygens. Which side, the before side or the after side, needs more oxygens? Definitely the after. Do you see there's only 2 there, and over here there's 3? So this is a 1 right now. I can notch it up to 2, and that gives me 2 O2s. Now how many oxygens do I have on this side? 4, which isn't going to work over here because that's 3. Now which side needs more? The left side does. Needs more oxygens, right? So I'm going to come in here, and I'm going to notch this up to 2 because if you don't have anything, it's 1, right? And so there we go. There's my second one of those. Now let's see. I have 6 oxygens, right? 2 times 3 is 6, or I can just look down here and see I've got 6. So is this balanced? No, I've only got 4 over there. So which side, the left or the right side, needs more now? This side needs more. I'm going to erase this number. Boop. And I'm going to come in here. What number goes here now? 3. I have 3 oxygens. 2, 4, 6. 3 plus 3 is 6. Yep, my oxygens are balanced. Are we done? No, the aluminums aren't balanced. Does the before side or the after side need more aluminums? Definitely the after side. Okay, I'm going to come in here. I'm going to erase that. And I want to know, what number do you think goes here? 4. If I put a 4 there, that gives me 4 of those aluminums. That's 1, 2, 3, 4 aluminums. And over here, I have 2, 4, 4 aluminums. It's balanced. Let's double check our oxygens to make sure we didn't mess them up. 3 plus 3 is 6. 2, 4, 6. We are good to go. That is a balanced equation. All right, fantastic. Now, I want you to balance this one. I will show you the answer to it right afterwards, but I want you to balance it and then type in the whole equation with the balanced coefficients in front of it. Okay, let me show you how I do it. I would say I have 1 of each one of these. I'm going to look at, let's say, I'm going to look at chlorine first. It looks to me like there's 3 chlorines over here and only 2 over there. So I'm going to put, I could notch this up to a 2, but you know that if I do that, that's only 4. That doesn't balance it. I'm actually going to notch this up to a 3, because if I do that, now I have how many chlorines? 6. And if I have 6 there, what number goes here? 2, because if I have 2 of those, now I have 6 chlorines. All right, let's do the borons. Let's see, what number needs to go here? 2, definitely, because if I had 2 borons, it would match the 2 borons over there. Let's double check everything, which we should always do at the end. 6 chlorines, 2, 4, 6 chlorines. 2 borons, 2 borons. So each time you notch up this coefficient, I want you to draw down 2 of these things, right? Each time you notch it up, draw down 2 of these things, but they have to be exactly the same. See how I didn't write just Cl? I wrote Cl2, Cl2, Cl2. And once you're done, you've got a balanced equation. All right, now my last tip before we go is gives you a little sort of tip to the next level. If you look at this one, you might look at this at first and go, ooh, that seems like there's a lot more going on there. But we're still going to put our balanced numbers on the coefficients. We're still going to divide things into the before and after. But I do have a tip for you to simplify these. So here's my tip for you. And you know if we have nothing on those lines, it just means we have one of them. By the way, if you end up with nothing on the line, you can just leave it as it is, or you can write the number 1. All right, now look at how ugly this thing is. It's huge. Still, you want to pick one atom at a time. But one of the things that makes this one a little bit harder is in the beginning, do you see what makes this thing look bigger is we have a polyatomic ion in here. Now you might think that's going to make things harder, but it actually isn't. Now, instead of just looking at, if you're sure you see a polyatomic ion, instead of just treating it as one single atom at a time, I usually start with the polyatomic ions. Here's why. Nitrate is a polyatomic ion. Do you see there's 3 of them there? Well, if I come over and see the nitrate, do you see nitrate is NO3? Do you see over here they don't have parentheses on it? I'm going to put parentheses outside it just like I did over there. You see how the parentheses are outside the NO and 3? How many NO3s are here? Just 1. So if there are 3 NO3s, 3 of those nitrates there, and only 1 there, don't you think we need more here? So treat the polyatomic ions as a group and it makes life so much easier. So now I have 3 of these things. Pretty good, so I'm going to write them down. That's 1 nitrate, 2 nitrates, 3 nitrates. That balances my 3 nitrates there. Good to go. Now we could choose any atom we want to next. Let's do, I don't know, let's do aluminum. Which side needs more aluminums? Neither. There's 1 over here and 1 over there. Good to go. Let's do chlorines. Which side needs more chlorines? Well, this side there's 3, and that side there's only 1. I think we're going to need more over here. Let's do that. So that's 3 NaCl's. Got to write down the whole compound because that coefficient affects the whole compound. That's 1, 2, 3 chlorines. 3 chlorines. Good to go. All right, let's do NAs. Which side needs more NAs? Neither. Because we put a 3 here, that's 1, 2, 3 NAs. 1, 2, 3 NAs. We might be balanced. Let's try the aluminums again. 1 aluminum, 1 aluminum. Chlorines, 3, 3. I think we're balanced. By the way, if there's nothing on these blanks, what could I put there? 1s, because it means there's 1 of them. But by the way, chemists, most of the time, don't put anything there. They just leave it blank, and we all know it means 1. So that's how you deal with polyatomic ions. Now this is our last one, and I want you to try this one. I want you to write it on your paper. And remember, if you see a polyatomic ion, I find start with the polyatomic ions and then do the rest. When you write it on your paper, put those coefficient lines on there so that you know that they're there. I mean, you know chemists don't really draw the lines, but if you want to, draw those lines. And then I want you to type in the coefficients that you get. All right, I'm going to divide it in half. And here's the before, there's the after. Okay? Now, when I look at this, I do the polyatomic ions first. Do you guys see there are 2 phosphates there? So over here, you might wonder how many are there? Some people think there's 4, but there's not really 4, right? Because do you see the parentheses over here, PO4? They just didn't put them on there because there was only 1, right? So if there's 2 phosphates here, I'm going to need 2 phosphates there. Now, it is a good idea. I will tell you that I often don't write down these sort of summary things, but it can be very helpful. So since we had 2 potassium phosphates, and over here, remember, we still have 1 of everything else. We haven't changed anything else. So I'm going to write down these other compounds exactly as they are. All right, our phosphates are balanced. We have 2 phosphates, 2 phosphates. Let's do potassiums next, K. Which side? Well, actually, let's start with this. How many Ks do you see on the before side? Did you see 6? There's 3 plus 3 is 6. Because remember, 2 times 3 is 6. If there's 2 of these things, there's got to be 6 potassiums, right? 2 times 3 is 6. Or you can just draw down 2 of those molecules and you can see it. Over here, there's just 1. So what number is going to have to go here? 6, because I need 6 of these Ks. That's 1, 2, 3, 4, 5. Going to need 1 more right like that. All right. Let's see. Let's do strontiums. Which side needs more strontiums? definitely the before side. I see 3 strontiums over here, so I'm going to put a 3 there. All right, our strontiums are balanced. And our phosphates, we had 2 phosphates, 2 phosphates. Looks pretty good. Strontiums, we just checked. Potassiums, there's still 6, and there's still 6. Always double check everything at the end, and then you're done. All right, the next thing we're going to do is we're going to stop. Before we get to the complex ones, we're going to practice these simple ones and make sure that you're feeling super comfortable with them before you go on. All right, great job today.